So today, guys, we're going to be doing part 2 of this slideshow. Okay, so part 1 was all about the first 10 or 11 slides, which was exponential functions, recognizing what it looks like, and understanding the basic transformations of it, and how to graph a growth or a decay and all that. We're going to skip ahead to maybe the 11th or 12th slide. Okay, so we're going to start at slide 12 here, and this is going to be, again, the beginning of part 2. Okay, and so what we're talking about here is the one-to-one property. And what this property talks about is it says again, remember, we're doing a to the x here. Okay, so instead of b to the x like we did when we graphed, we're doing a to the x. And again, a just represents the base. But what we're saying is that any time the a value is greater than 0 and the a value is not equal to 1, okay, a to some power is, if a to some power is equal to a to another power, then the powers must equal themselves. The x must equal the y. Now that sounds kind of complex, but let me show you with real numbers and it'll kind of make sense to you. So for example, if I happen to have like 2 to the third power equals 2 to the y power, then you know if the base is the same, both bases are 2, then you know that 3 must equal y. So y would be 3. Or I could do, I could give you a whole bunch of examples of problems like that, okay, where we're going to do that. And that's what we're going to practice. Now, you're not always given the same base, right? So sometimes you might have to change the larger base to a power of the smaller one. Now, let me give you an example of what that would look like. And so let's say I have a problem like 8 equals 2 to the x power. Well, my bases aren't the same, so I can't use this strategy I just learned about this one-to-one power. But what if I can take this larger number and turn it into some base of 2, right? So when I think about it, I'm like, well, hey, wait a minute. 8 is 2 to the third power. So 2 to the third power equals 2 to the x, and I'm like, oh, now my base is the same, so I can kind of cancel it and say, okay, well then x must be 3. And so, again, we're going to do a lot of problems like this, and it's going to become easier, but that's really what we're talking about. And again, the most important thing here is to try to get the bases to match, okay? You also have just a reminder that anything raised to the 0 power equals 1. So let's get to some problems here, right? We're like, let's look at number 15. We've got 9 equals 3. So this is really 9 equals 3 to the x plus 1 power up here. Okay, that's the exponent. I know it's a little hard to see in the picture. So my base is 3. So first thing I'm going to start and think, well, can I change 9 to a base of 3? Yes, 9 is 3 squared. So 3 squared equals 3 to the x plus 1 power. Now, since my bases are the same, I can cancel them and I can do 2 equals x plus 1. Now I just solve for x using basic algebra skills. So x is 1. And so that's the solution. And again, if you want to try, do that. Plug it in to check your answers, right? You can always check. 9 equals 3 to the x plus 1 power. 9 equals 3 to the second power. 9 equals 9. Yeah, it works. So x is 1, okay? So I come to the next problem, and I'm like, this one's a little bit more challenging because I'm like, okay, I have a fraction raised to the x power equals 8. Well, first of all, a fraction's kind of difficult. But I can kind of think of a fraction a little bit different, right? First of all, let's just talk about the bases. This one has a 2 in it, and this has an 8. Well, I know that I can convert these both to something with a base of 2. Now, 1/2, guys, is also, if I think about it, it's also 2 to the negative 1 power raised to the x, right? So I'm basically rewriting what's inside of this parentheses here, and I'm rewriting 1 over 2 as 2 to the negative 1 power. And then on the other side, I know 8 is 2 to the third power. Now, before I can do my one-to-one property and figure out my exponents, what I have to do is I have to get my bases the same. And while these are both 2, right now this is 2 to the negative 1, raised to the x. So I have to raise this power to the power first. And remember, when you do that, you multiply. So this becomes 2 to the negative 1x power, and that equals 2 to the third power. Now that my bases are both 2, I can do negative 1x equals 3. If I divide both sides by negative 1 or multiply, I'm going to get that x is negative 3. And that would be my answer. Okay, and again, if I want to check it, and I'm not asking you to check them all, but it's wise at first to probably do it. If I do 1/2 to the negative 3 power, that's going to be 2 to the third power, which is 8 equals 8, and it works. So I know my answer is correct. Okay, so we keep going. This one's a little bit easier, right? So we have 8 equals 2 to the 2x minus 1 power. 8, I can convert that to 2/3 equals 2 to the 2x minus 1 power because my bases are the same. I do 3 equals 2x minus 1. And then I'm just going to do the math to solve for x in here. So I divide by 2, and I'm going to get that x equals 2. And there's the solution. So that's the application of the property. And now we're just going to do a bunch of examples. So again, the examples can get easier or more challenging. I mean, it is what it is. I'm going to start 18 I'm going to get rid of that negative exponent by flipping my fraction. I know 3 over 1, which is just 3, to the x power equals 27. Now I'm able to see that I can convert 27 to 3 cubed. Okay, and so now that my bases are the same, I know that x is 3. And again, you can always check by plugging it in and see that confirm that it works. Okay. Over here in this next one, I have 1/3 to the x power equals 81. Well, first of all, I'm going to leave this as 1/3 for right now. I know that 81 is 3 to the 4th power. Okay, so if I can just change this first one to a base of 3, I'm going to be able to use the property. And I can. I know that 3 to the negative 1 power to the x is going to equal 3 to the 4th, right? So I know that 1/3, again, what's inside this parentheses translates to 3 to the negative 1 power. And then it's still raised to the x out here, right? So I know that a power to a power gets multiplied. So that's minus x, and this is 3 to the 4th. So again, now that I have my base the same, I know that negative x equals 4. And if I multiply or divide by a negative number, I know that positive x, is going to equal negative 4. And that's my solution. So, and this is how we do it. The problems get a little bit more complex each time, but same strategies. Here I have 2 raised to the x plus 4 power equals 8 raised to the x minus 6 power, right? So first of all, I'm just kind of going to put my bases in parentheses. I feel like that makes it a little easier. Well, 2 to the x plus 4th power doesn't have to change anything. I don't have to change it. Now 8, I know 8 is 2 cubed, okay? And it's still raised to the x minus 6 power. So I was able to convert 8 to a base of 2 with an exponent. Now what I'm going to have to do is I'm going to have to raise this power to power. So that, because what I want is I want to get the 2's by themselves in the parentheses so that I can cancel them out. So I know that a power to power is going to be 3 times x minus 6. I have to remember to put that x minus 6 as a group because that 3 does have to be multiplied to both of the terms. So now I know that these can cancel, and I'm going to get x plus 4 equals 3 times x minus 6. So I'm going to start by distributing the 3x minus 18, and then I'm just going to start solving. I can do minus 3x rather, right? That's going to leave me with minus 2x plus 4 equals 18, or negative 18, sorry. Then I'm going to subtract 4 from both sides. I'm going to get minus 2x equals minus 22. And I'll divide by minus 2. And I'll get x equals positive 11. So that works. Okay, so x is positive 11. And again, you can always check your work. So we're just going to do lots and lots more problems. I'd suggest you practice all of these. Every scenario is here. So 2 to the 3 minus x power equals 2 cubed, right? Because I'm going to convert 8 to 2 cubed. And then I know that 3 minus x equals 3. Minus x equals, I'm going to subtract 3 from both sides. I'm going to get minus x equals 0. And so guess what? X just equals 0, which is possible. X can equal 0. Again, I keep going here. I've got 5 to the 2x plus 1 power equals, and 25 is 5 squared. So 2x plus 1 equals 2. Subtract 1 from both sides. 2x equals 1, and x equals a half. Again, I can have x equaling 0 or a negative number. X can be a fraction. Now e, again, remember that e is a natural number, so it's a little bit different. But again, I just need to make sure both my bases are e. So here I have e to the 4x minus 1 power. And here I have this power to power, so it's e to the 2 times x power. Now that I have, my e kind of by itself, I can cancel it. And 4x minus 1 equals 2x. Subtract 4x from both sides. Minus 1 equals minus 2x, divide by minus 2, right? And I get x equals a positive 1/2, which is a great answer. Again, we keep going. Sometimes you've got to change both of them to get them to the same base, right? So when I see 27 and 9, I'm like, okay, I've got this. Let me just put it in parentheses first. 27 to the 4x power equals 9 to the x plus 1 power. I'm going to make both of these have a base of 3. 27 is 3 cubed raised to the 4x power, and 9 is 3 squared raised to the x plus 1 power. So I'm almost there. Now, since I want 3 by itself, I'm going to raise my power to power here. So 3 to the 3 times 4x power, which is 12x power, is going to equal 3 over here to the 2 times x plus 1 power. Okay, and again, I have to remember that I have to distribute that too. So my 3's cancel, and it leaves me with 12x equals 2x plus 2. Subtract 2x. 10x equals 2. X equals 2 over 10, or 1/5. And there's my answer. So we just keep going. Sometimes, like I said, you have to do both of them. Sometimes it just requires changing the base on one. On this one, I see that 4, again, I kind of like to write it, I sort of like to group the base or put a parentheses around it just to kind of recognize what I'm doing here. And so I know that 4, I can substitute a base of 2 there because 2 squared is 4 to the x minus 2 power, and then this is 2 to the 3x plus 3 power. I know that I have to raise this power to the power so that I can get 2 on its own. So it's 2 to the 2 times x minus 2 power equals 2 to the 3x plus 3 power. Now that I have my base the same, I can make my exponents 2 times x minus 2 equals 3x plus 3. I can make them equal to each other. Distribute the 2, and then just solve for x. So it'll take me a little bit. I'm going to subtract 3x from both sides. Negative x minus 4 is 3. Add 4 to both sides. I get negative x equals 7. And if I divide or multiply by negative 1, I'll get x equals negative 7. And that's my solution. Again, here I have e, and e is just, again, confusing. We talk about it in class, but it's not any different than anything else. You can basically, in these problems, treat e as any old variable like a or b or x, and you're just going to get the base to be the same. So you want your base to be e here. Now, e is different than variables because e actually has a set value. We'll talk about that a little bit more in the upcoming sections, but right now we're just going to treat it like a variable, and I'm going to say that 1 over e is equal to e to the negative 1 power to the negative x, and 1 over e squared is e to the negative 2 power to the x plus 1. And so I notice if I just raise my powers to powers here, I'm going to get a base of e. So I'm going to get e to the negative 1 times negative x, which is just x. And here I'm going to get e to the negative 2 times x plus 1 power. So my e's are going to cancel because my bases are now the same, and my exponents are going to be equal to each other. So I'm going to distribute and solve. So minus 2x minus 2, I'll add 2x to both sides, and I'm going to get 3x equals minus 2, and so x equals minus 2/3, and that's the answer. So again, same concepts over and over and over again, just different applications. You know, maybe it's in the numerator, maybe it's a denominator. You want to be comfortable with turning a denominator to a, make it a numerator with a negative exponent and things like that. So we have 3 more problems here. These are a little bit different, so I kind of like going over these. So the first one is the square root of 2 raised to the x plus 4 power. Now, the square root of 2, if you recall, back when we did going from radicals to exponents and exponents to radicals, we realized that a square root is basically the same as a 1/2 power, okay? So this is 2 to the 1/2 power, and on this other side, it would be 2 squared to the x power. So I'm kind of able to get it down to that. Now, just to kind of refresh, how did, square root of 2 end up equaling 2 to the 1/2 power? Let me just remind you, right, that this is really 2 to like the first power, right? And the square root has an index of 2. And so we take this power here and it becomes our numerator. And we take the index here and it becomes our denominator. So, for example, if I had, let's say the cube root of 2 to the 4th power, right, then this would be 2 to the 4/3 power. Again, this would be the numerator, and this root or index is our denominator. And so again, I just wanted to refresh how to convert from a radical to a fractional exponent. So that's how we got the 1/2 power, is the 1 and the 2 there, okay? So again, now that I have this though, right, again, my base is 2, so I'm going to have to raise the power to power thing here. So I'm going to do 2, and then I'm going to do 1/2 times x plus 4 equals 2 to the 2x power. Again, my base is the same, so I can now make my exponents equal to each other and solve. So I'm going to distribute the half. So I have 1/2 x plus 2, half of 4 is 2, equals 2x. Now, I could work with the half here. I'm not a fan of working with the half, but I can. I can subtract 1/2 x from both sides, okay? I know that's going to be 2 equals 1.5 x, or I can say 2 equals 3 over 2x, and I know that I'm going to multiply by 2/3 to get this to x, right? So I'm going to get x equals, and I'm going to get 4/3, and that is the answer. Now, I will give you an easier way to do it. Instead of working with that fraction, I'm going to kind of go back and go back to here, and if I just take this denominator 2 and I multiply every term here by 2, look what's going to happen. I'm going to get x plus 4 equals 4x, and now I don't have to worry about any fractions. I'm going to end up, I promise you, with the same answer. Notice, x is 4/3. It is the same answer, but it's a lot easier. And when you learn to work with fractions by, in essence, eliminating the fractions, it's going to make your life a lot easier, okay? Now we get to some where it's a little bit different, because up until now we had a to the x equals a to the y. We canceled the a's, the bases, and we said, oh, the exponents equal themselves, right? Well, what happens if I have something like, let me do different letters, right? But let's say I have p to the 3rd equals r to the 3rd. Well, then we know that p and r must be equal to each other, because if think of it as numbers, right? If I do, 2 to the 5th power equals x to the 5th power, then we know that x has to be 2. It has to be the same thing. So that's what we're going to be doing in this one. We have 1 over 27 equals b to the 3rd power, okay? Well, first of all, let me get this as a number, right? I don't want it as a fraction. So 1 over 27 is the same as 3 to the negative 3 power. So 3 to the negative 3 power equals b to the negative 3 power. Well, if the exponents are the same, then 3 has to equal b, or b has to equal 3. And so that's one way to do it. The other way I could have done it, again, there's multiple ways. I could have stuck with the denominator here, and I could have made b to the negative third equal to 1 over b cubed. And then I can turn 27 into 1 over 3 cubed equals 1 over b cubed. And either way, you're going to see that b and 3 have to be equal. Okay. The last one's a little bit different too, but it's kind of cool. What happens on this one is what I have right now is r to the 2/3 power. And so I'm not going to be able to get this base to equal r. That's just never going to happen, right? So what I could do is I could raise this side to a power that will eliminate that fraction. So for example, if I raise it to the reciprocal, remember that anything raised to the reciprocal, if I multiply reciprocals, they end up equaling 1, okay? So if I do the same thing on this side and raise this to the 3/2 power, that's what r in essence equals. R equals 4 to the 3/2 power. And let me work that out. 4 to the 3/2 power is 4 cubed and the square root of that. Now I can cube 4 first and then take the square root, or I could, and this is what I always prefer to do, if possible, I like to take the square root first and then cube it. I like to go smaller and then go bigger by cubing, okay? And I get 8. So r is 8, and that is the answer, okay? Now, there's a couple things I could again do. You know, I always like to make things easy. Some people don't like to multiply by reciprocals, so you could have done this in 2 steps. You started with 4 equals r to the 2/3 power. I could have raised this to the 3rd, okay? Because 2/3 times 3 is just 2. And this would be r cubed is 64. And then I could take the square root, and I would get that r is 8. Either way, I'm going to get 8. But I could do it in 2 steps. I could first cube it, then I could take the square root of it, or I could do it all in one shot. And that's going to just be your comfort zone. You're going to end up with the right answer. Whatever you do to this right side, you just have to remember you have to do it to the left side for it to stay balanced, and you'll be fine. Now we're going to stop here again because this is the end of part 2, okay? So the last slide 18 through 21, that's going to be in part 3, okay? And that's going to be about compound interest and using this variable e that we've been talking about, or this letter e, not variable but letter, to represent this natural number. And we'll talk about that in the next video. So there'll be a really short video on that.